Hello everyone, welcome to the CloudLearn AWS Zero to Hero series. This is a day 24 video, and in this video, we are going to perform some hands-on exercises on the Elastic Load Balancer service. In the previous video, we have seen the theory part about the Elastic Load Balancer, right? In this video, we will perform some practicals. Okay, so in this hands-on exercise, we are going to implement an application load balancer in order to distribute the traffic across two targets, across two different servers. And in these two servers, my company's website is hosted. So I have some company, right? And I need to maintain a website for my company, like in which I will display what kind of services I offer and all. And for load balancing and high availability, I'm going to use application load balance. In the real time on both the servers, we call them as a targets, right? We call these as a targets. In the real time on both the targets, the same website will be hosted so that the end users don't know that to which server they got connected. That's why even whenever you open yahoo.com or google.com, they might have a multiple servers, but we don't know to which server we got connected. Everything will be managed in the backend. But as we are in the learning phase, and practically, we should observe that the users are getting distributed across multiple targets. That's why I use two different websites. That means if any user got connected to server 1, they will see welcome to server 1. If they got connected to server 2, they should see welcome to server 2, means two different websites. Already I downloaded some sample code for my website because we are not the developers, right? But that's a simple HTML code. What it will do is it will display you are connected to the CloudLearn US East 1A, which is server 1. For the second server, I can say you are connected to the CloudLearn in US East 1B, server 2, server 1 and server 2. I mean, like I would like to display to which server you got connected. Okay. So what all we have to do now? First, I need to create a two servers, server 1 and server 2. They should be across two different availability zones, not only for load balancing, for high availability. Then in each server, I will run a different website just for identification purpose. But in the real time, they use the same website. Okay, right. So here, let me write down the steps. Create an application load balancer to distribute the website traffic across two EC2 instances. Okay, now let me write down the steps. Create two Linux EC2 instances in 1A and 1B availability zones. Why in two different availability zones? For high availability. Then host simple website on both Linux EC2 instances. I will provide the code at the end of this document. Then verify that the websites are accessible using public IP. Right? Once everything is done, create target group and register the above two EC2 instances as targets. Means these two EC2 instances must be included into the target group. That is what? Registration. Then create application load balancer and point to the above target group. Means whatever the traffic is received by the application load balancer, that should be forwarded to this particular target group. Okay, so here, because these are the Linux machines, for the one machine I will explain how to run a website and all the things like host a simple website on both Linux EC2 instances. So here, host a simple website on Linux EC2 instance. Because I assume majority of the people doesn't know what is this Linux commands and all. So that's why I will give you some basic things. So first we need to create, right? Let me create two Linux EC2 instances quickly. Let me navigate to the EC2 service. Make sure that I am in the Northern Virginia region. So how to create, just go to the instances, launch instance. So here I will give a name called server one. I will use Amazon Linux. That's okay for us. And T2.micro because it's a free tier. I will choose that. Keep here, Northern Virginia. Let me check that I have access to that key. I think I haven't deleted any. So I might have that key. Yeah, I do. So then network settings, edit. So subnet, I will choose 1A. Here, this is the one 1A. Auto assign public IP, yes. Security group. Okay. So what traffic to be allowed? Because it's a Linux machine, right? So I have to allow first one SSH, then HTTP and HTTPS. These are the protocols to be allowed because here I don't have SSL certificate, so I am not running my website on HTTPS, but in the real time, everyone will run on HTTPS. Okay, see here, type of traffic SSH will be allowed from anywhere. Then I will click on add security group rule, type HTTP, here it is, source type anywhere. Then again, add security group rule, HTTPS, source type anywhere means I'm allowing HTTP and HTTPS. These are for website access. SSH for log into the Linux machine from a remote location. Storage 8 GB, that is more than enough for me. Click on launch instance. So server 1 is getting created. While it is getting created, let me create server 2 also. View all instances. So the same procedure I will perform again, but with a different availability zone. See here, server 2, Amazon Linux. Instance type t2.micro, key pair, the same key pair, edit. Subnet is going to be 1B. I mean, other than 1A, anything other than 1A. But I don't want to create a security group again because already we created one. Let me select existing security group and here I will choose this one because in that already we exempted SSH, HTTP and HTTPS. So these two EC2 instances are getting created. So to host a website, I will show on server 1. You guys have to repeat the same thing on the server 2. So first let me log into server 1. How to log in? We need a public IP and we need a putty tool, right? Let me open the putty tool. So here you need to enter the public IP. On the left side, expand SSH, expand authentication, credentials. Then on the right side, click on browse and choose the private key. So here, what I do is I will increase the font size, accept, and what is the username? EC2-user. You can go back to EC2 concept to know how to create Linux machines, how to log in and all. Okay, right. So I logged in. Now what I have to do, first I need to update it. So here I will provide you some steps. First thing, update the M repository. For that, what is the command is sudo space yum update. This is the command. Whatever you can see this hash, that is a comment. Okay, and this is going to be the actual command. What it will do, it will update the M repository, like a kind of a software Google Play Store in your mobile phone. M update, sorry, it requires sudo. Sudo means with admin privileges. If you are not comfortable with sudo and all, then you can switch to the root user also. For that, you can type sudo space su. So for now, see here, with which user we logged in? EC2-user. If I do sudo su, with which user? Root user. Means no need to type that sudo in front of every command. To come out of that, I will do exit. Okay. If you want to know with which user you logged in, you have a command called who am I. Sorry, who am I? With which user? EC2-user. Okay. So then to host any website, we need a web server. So here install httpd web server. What is the command? Sudo space yum install httpd. This is the command. Sudo space yum install httpd. So it will download and it will install httpd software, which is a web server to run HTML websites and all. Okay, is this okay to download and install? Yes. Type Y and press enter, and it got installed. And once the web server got installed, we need to start the HTTPD service manually. It won't start automatically. For that, service HTTPD start is the command. If you want to check the status before starting, you can do service HTTPD status. What is the status? Inactive means the service is not running. So how to start? Like this: sudo space service space HTTPD space start. But here the problem is, now let me check the status. Now we can see active. That's cool. Now here the problem is, whenever whenever you restart your EC2 instance, that service won't start automatically. That is the main problem. The service won't start automatically. For that reason, what we have to do is configure the HTTPD service to be started automatically every time whenever you restart the computer. For that, the command is always that HTTPD service will be on. This is the command: sudo space chkconfig space HTTPD space on. If you restart your computer, the service will be started automatically. Now, host the website. So what we have to do is cd space var www html, which means sorry, your web pages to be placed in this location. In your Windows machine, the directory path will be c colon slash what we call that program files or something else, right? But in the Linux, it starts with slash. There's a root directory. Your website to be placed here. So vi space, I mean the sudo vi space index.html. That is my web page in which I will copy paste all my content. Okay, right. So here, let me open this cd space. Okay, first let me type pwd, which means present working directory. In which directory I am in? Slash home slash ec2 dash user. But where I have to create my web pages, slash var www slash html, which means first we have to cd means change directory, var www html. Now check pwd. Make sure that you are in this location. Then only create it. How? Sudo space vi space index.html. Now you need to press I. I means insert mode. Now you can insert whatever you want to in that particular file. You can check here on the bottom left corner as an insert. Now I will copy this. That is a web page code, and I will right click. Automatically it will be pasted. Okay. Right. So let me now how to save it. Press escape button. Now shift colon. You can see on the bottom left corner colon symbol. Shift colon WQ. Write and quit. Press enter. That's it. Done. The website is ready. How to verify? Just go to the EC2 instance public IP. Open a browser. See here. We hosted the website on server 1. Now the same thing I have to repeat on server 2. Wait. Okay. 1 second, guys. On which machine we did all these things? Okay, server 1, 119.65, 119. Okay, that's correct. Right, so now I have to log into the server 2 and I need to repeat all the things again. How to do that? Let me exit from the server 1. Let me open, I will repeat the same steps. I will show you, but not detailed quickly. Only difference is instead of server 1, I will mention server 2 just for differentiation purpose. Okay, right. Forgot to increase the font size. Let me do it now. Change settings, appearance, change 18 bold, bold. Okay, I think it's clear now. The same things I will repeat one more time on a different server. Okay, so here what I do is mm, this I will change to 1B, and here this I will change to server 2. Okay, a different web page for a different server. Done. Exit, exit. Server 2, let me check whether the website on server 2 is working or not. Yes. See here, differentiation. Right. So now it's time to go for target group and load balancer. So we have done up to C, right? Step C. Now create target group. Let me do like my first TG, just name of the target group. You have to give some name. I will use my first TG, the name of the target group. Okay, how to do that? Just go to EC2 service. On the left side, scroll down to the bottom, and you can see one option called load balancing under target groups. Click on create target group. What is our target? Instances, right? EC2 instance. You can choose IP address, or you can go with Lambda, or you can distribute the traffic to another application load balancer also. But here I'm choosing instances. Target group name, my first TG. My website protocol is HTTP. VPC, just you can keep all default options. Health check protocol, HTTP, advanced health checks, Healthy threshold 5 means if the website is accessible continuously for 5 times, it will consider the target is healthy. If continuously 2 times, if the website is not accessible on 80 port, then the target is considered as unhealthy. Timeout means it will wait for 5 seconds to get a success code. I mean, if it's trying to access the website on server 1, it will wait for 5 seconds to get a response. Within 5 seconds, it won't receive a response. Then it will say, okay, failed. Interval, I will say 10 seconds. Like every 10 seconds, I would like to check the health of both the servers. Keep the success code 200 because whenever there is a response from the server, the status code will be 200. Now click on next. Select those two EC2 instances, and here you must select include as pending below. First, they will be added as a pending targets. After successful health check, they will be converted into either healthy or unhealthy. And click on create target group. Now we created the target group and we added two instances as the targets. Initially, the status will be pending, then they will be changed to either healthy or unhealthy. Okay, now just here, click on load balancers on the left side, create load balancer. Here, application load balancer, network load balancer, gateway load balancer. I think it will be more clear to you, which supports TCP, UDP, TLS is a network load balancer. Application load balancer supports HTTP and HTTPS. Classic load balancer is a previous generation. So here, click on create under application load balancer. Load balancer name, my first strategy, internet facing means your load balancer will be faced to the internet. And here, just there is no wrong in selecting all availability zones. There is no wrong, but minimum you have to choose any two for high availability. Security group. What security group we need? We need minimum HTTP and HTTPS because whenever a user is trying to access the website, they send a request on HTTP and HTTPS. We don't have a separate HTTP, HTTPS security group. So here I will click this link. A new tab will be opened for security group creation. I will say HTTP, HTTPS, in which I will create two inbound rules. One is for HTTP, source anywhere. The next one, HTTPS, source anywhere, and just click on create security group. So I create one security group which allows HTTP and HTTPS traffic. Now I closed it. So here, just I will do a refresh button here, remove the default security group and this one. Select HTTP, HTTPS. Now, listener and routing. Whatever the traffic is received by the load balancer for 80 port, that has to be forwarded to which target group? My first teach. Now scroll down. Ignore this web application firewall for now. We will discuss what we call that about web application firewall in the next coming sessions. Scroll down and click on create load balance. So what is the status here? Provisioning. You have to wait for few minutes. You have to wait for few minutes so that they will generate it. See here, load balancer DNS name. This is the load balancer DNS name. Let me write down it. So your websites will be accessible using this particular DNS name. Now you might say, okay, my company name is ABC. I would like to access the websites with abc.com, not this complex website name. For that, this is mandatory, but we have a service called Route 53 in which we will create alias record. What we will do, abc.com will be pointed to this lengthy DNS name. What happens here is whenever a user types abc.com, automatically the request will be forwarded to this particular load balancer DNS name. That is going to happen in the backend. That is going to happen in the backend. So we don't need to worry about the users will see this kind of a complex names and all. They only see your company's name, abc.com. Okay, right. So now let me go back to our EC2, I mean the load balancer. Let me refresh to check the status. Still, it is provisioning, which will take a few minutes. Let me go back to the load balancer. State is provisioning. Select that load balancer. State is provisioning. Okay. Now I will go to the target groups. This is the target group, right? Let me click on that. And here, targets. What is the health status? Unused. Let me refresh. What is the health status now? Initial means they are initializing a health check. The moment once the health check is passed, these will be added into healthy. If the health checks didn't pass, then they will be added as an unhealthy. Just wait for like few seconds. Okay, if you remember, we are verifying for 5 times continuously. Each time it will take 10 seconds, right? Means total it will take 50 seconds of time to make any target as a healthy. The same way it will take maximum 20 seconds to make a or to decide any target as an unhealthy. Okay, now what is the status? All two are healthy. Okay, now let me go back to the load balancers. Active. Now here, let me use the DNS name. Okay, so now let's check this DNS name. So I got connected to server one, right? If I do a refresh, there is a kind of a second user, right? Server two. Again, if I do a refresh, server one, server two means whenever I do a refresh, it consider me that as a new user. So it distribute the traffic to a different server. This is how the load balancing happened. Now the question, how high availability is possible? For that reason, what I do is I will go to the EC2 and I will stop any one EC2 instance. Out of those two targets, I will stop one EC2 instance. Let me stop server 2, which means within 10 seconds, I mean within 20 seconds, the health check fails. Maximum time is 20 seconds, but within 10 seconds only it will be identified. The moment once the server 2 is unhealthy, the target group identifies that all the traffic should be forwarded to server 1 only. That also will verify. Once the server 2 is stopped, I will refresh the page and I will show you that all my requests, how many times I refresh, those many times I will be connected to server 1 only. See here, I got connected to server 1, now refreshed. You can observe here, whenever I click on refresh button, you can see something here on the tab. Refresh. I'm refreshing like multiple times. As the server 2 is unhealthy, I will be connected to the server 1. I mean, everyone will be connected to server 1 only, which is a healthy. Now, I will do one thing. Let me go to the target groups. Let me do a refresh once. Select the target group. Targets. What is the status of server 2? Unused. What is the reason? It is in stopped state. Okay, now I will go back to instances. Let me start it. Once it got started completely, within 50 seconds, it will be identified as a healthy server because 5 times it has to be checked. Each time it will take 10 seconds. 5 into 10, 50 seconds. Maximum it will take 50 seconds to make that server healthy or identify that server as a healthy. Once it is identified as a healthy, every time I click on refresh or every time a new user is trying to connect, traffic will be distributed across both the servers. I'm already refreshing. Still, the server 1 is not healthy. Let me open the target groups in new tab. And this is our target group. How many are unhealthy? One is unhealthy, which is server 2. The moment once it is healthy, automatically the traffic will be distributed. We will verify that and then we will close this video. Without verifying the practical things, we can't understand it properly. See here, server 2, because that's already healthy. It's become online and the website is accessible. And this is how the high availability is possible with the help of load balancer. This is for application load balancer hands-on video. If you have any questions or if you have any doubts with this application load balancer, feel free to reach me on the comment section. I will be happy to help you. Thank you, everyone.